In this video, I'm going to explain how transformers work. I'll also give you a quick peek at how you can go from mains electricity to creating a dual-rail DC power supply. So, what is an electrical transformer? A transformer is a device that takes electricity, turns it into a magnetic field, then turns it back into electricity again. Depending on how the transformer is designed, you can use them to step up voltages, step down voltages, or even keep the voltages the same if all you want is electrical isolation from your wall outlet. So basically, transformers help you get from one voltage to another. And when you remove the protective casing, all transformers end up looking kind of like this, with a bunch of wires wound around an iron or ferrite core. Transformers only work with AC. An AC voltage on the input creates an expanding and collapsing magnetic field within the transformer's core. Now, when you put this alternating magnetic field in the presence of another coil, the moving magnetic flux will induce electrical current into the secondary coil, so you'll get another AC voltage on the output. Here I have a transformer that takes 120 volts on the input and gives you 12 volts on the output, so we call it a step-down transformer. Now, just for fun, I'm going to use a magnetic field probe, and if I move it near a transformer that's in use, you can see the magnetic field expanding and collapsing at 60 Hz. That's because stray magnetism is inducing current into my probe. The same thing is happening on the secondary side of the transformer, but obviously more efficiently, so I get the full 12 volts. But with DC, the magnetic field would stay still, so no current would be induced in the secondary coil, and nothing would happen. The simple theoretical model of a transformer will usually show you the turns ratio. The turns ratio is how you know if you're stepping voltage up or down and by how much. And when I say turns, I mean literally the number of times the wire was wound around the transformer's core. The left side is called the primary side, and this is where you connect your input voltage. The right side is called the secondary side, and this is where you connect your load. The ratio of V in to V out is the same as the ratio of primary turns to secondary turns. So if you have a transformer with a 10-to-1 ratio, it will divide the input voltage by 10, and that's what you'll get on the output. In the real world, transformers behave a lot more like this, or sometimes this. It gets complicated. In other words, transformers have all kinds of inductances, resistances, capacitances, and magnetic hysteretic effects, and if you're new to working with transformers, you should be buying a brand new transformer specifically designed for your purposes. Don't try to salvage transformers off of old PCBs and expect them to work with mains voltages. Transformers tend to work best only at certain frequencies. So let's talk about how to buy a transformer for your first project. For the rest of this tutorial, I'm going to be working with a transformer that I bought to convert 120 volts at 60 Hz AC down to 24 volts AC. You could use a transformer like this as part of a homemade guitar amplifier, or possibly a bench power supply. You can get transformers like this at jamico.com. Just search for transformer and you'll see various options with different output voltages and current ratings. If you see the term CT or numbers like 12012, that means it's a center tap transformer, which means you'll have the choice of having the full 24 volts AC or splitting it up into two 12-volt supplies. Now, if your transformer is rated in VA instead of amps, you might be wondering what that means. Well, basically you can think of VA as being equal to the power rating of the transformer in watts. Now, that's technically incorrect, but for anything a beginner is designing, they might as well be the same thing. So, if you think your project will draw 50 watts, buy a 75 VA transformer so you have a bit of a safety margin. If you want more information on what VA means, Google volt ampere and power factor. Working backwards, for the 45 VA transformer I bought here, the max load that I would try put on it is about 30 watts just for the sake of having a nice safety margin. And I should probably keep an eye on the temperature too. So pick your voltages, figure out how much current your transformer needs to handle. Do you see how the label says 12012 volts? Well, instead of calling the outer terminal ground, let's call the center terminal ground and see what's happening on the oscilloscope. The two waveforms are in opposite polarity. This makes sense because we're effectively splitting the secondary coil into two pieces and measuring voltages with respect to the center tap. So having a center tap transformer gives you the option to have a negative voltage at the exact same time that you have a positive voltage, and this is very useful when designing dual rail power supplies.